I'll now be creating my basic character camera, and this will be a third-person camera which will revolve around the player. So we'll have our third-person character. The camera will be placed at the character. Originally we'll place it at the character's feet, although I may move this to be slightly in front of the character. We may also eventually want to move the camera to either side of the character and add the ability to change this pivot position. This, however, will happen later. So we're going to have a single offset, which will be an offset in height. This will prevent the camera from pointing towards the character's feet. We'll also want to be able to specify this offset in both position and height. So we need a vector that will point upwards. We'll then need a vector which will point away from the character. The length of this vector will define the camera's distance from the player, or more precisely, it will define the distance from the camera to the camera target. The camera will then point in the opposite direction to this vector. So essentially we'll have two main vectors which we're going to calculate now. One will have a translation and a height. The other will be rotated and will be rotated on two axes. We're not going to be adding any spin to this camera. This can be done, but it's not necessary in this case. So we've got our Unity project, and for the moment I'm going to reorganize this, and I'll move my game window beneath my hierarchy. This will not give me a particularly good view of the game, but I will want to be able to follow what's happening in the scene more closely than the game window at the moment. Certain gizmos will not show up properly in both windows. Our view of the entities will also differ between the viewports. So we'll want to make sure that my gizmos are on in the game view. I'll then update the starting point from my viewport. In my hierarchy, I'll select the camera game object. I'll then open the game object dropdown, and I'll select Align with View. This will align my camera to the scene camera. This view will give me a better idea of what is happening in the space around the character. It will also make it easier to read my debug gizmos. Before I work on the camera, I want to make some small corrections to the player. Currently, the position of the capsule is being set by the player, and this is being positioned at 1 in the y-axis. The capsule should actually be positioned by itself. The player should be starting at 0. So for the player position, we'll change the y value to be 0. I can then enter the player prefab, and I can raise the capsule to be 1 in y. We can now work on the camera scripts. We can open the player camera system, but this is not actually where we're going to calculate the position of the player camera. For the moment, we're actually going to be calculating this on the player itself. Since this will be happening within the player system, we'll need to update our authoring, and there are some components which I want to add to the player. The first of these will be a public struct called camera position. This will implement iComponent data, and is going to store our final position for the camera. Since this is a position, we'll need a float3. This variable will be called value. This should be a public float3. I'll also want the position where the camera is actually pointing towards. This will be the camera target. This will also have a value which is a float3. We'll have our next component, which will also be a public struct. This will be camera offset, and this will also be a float3. I'll then have a public struct, and this will be called camera distance. It will implement iComponent data, and this value will be a public float. We'll now need to add these components to the entities, so I'll duplicate the line where I add the player tag. I'll add the camera position. We'll have the camera target. After this, I'll have my camera offset. The camera offset is a value which we are going to update within the editor. Because of this, I want to add a value to my authoring model behavior. I'll add my first value here, and it will be a float3. This will be called camera offset. After this, I'll have a float, and this will be for my camera distance. I'll set this to be 1 by default, so the value will be 1.0f. This shouldn't be the position, it should be the distance. In order to use the values from the model behavior in our entities, we'll need to initialize the component. So I'll place a couple of curly braces after camera offset. Here I'll set the value, and I'll set this to be equal to authoring. My values are not showing up here, and this is because I forgot to specify that these are public variables. So my camera offset will be set by my authoring.cameraOffset. We'll then use add component again. This will be added to our player entity, and we're going to add the value for our camera distance. I'll also initialize this with curly braces. We'll set our value here, and this will be set with authoring.cameraDistance. This will give us all the updates we require for the camera on the player. In Unity, if I select the player, we should now see extra parameters in our inspector, and these will give us the camera offset, as well as the camera distance. Here I want to make sure that the offset is 1 in Y. I'll also increase the camera distance. We can now return to our script, and we're going to work on the player system. I'll need to update my input. Currently we have a stick to move the player. We'll also need a stick to move the camera. So I want to create a reference for the left stick. This will look for the left stick component, and it will look for this in our input entity. So now we'll need to calculate the rotation. I'll start with our rotation in X. So this will be rot.x. We do not, however, have a variable for this yet. We'll have a float 3, and this will be called rot, and this will be initialized as a 0 vector. I can now set the rotation in X to be set by our left stick, .value.y. I'll multiply this by delta time, and to give this a slightly larger value, I'll multiply it by 2 for the moment. We can eventually look at adding proper speed parameters, or we can end up replacing this with physics algorithms, or driving them through damping parameters. But for the moment, I'm just going to accelerate this. I'll duplicate this line. However, this will be for our rotation in Y, and I'm going to set it with the X value from my left stick. So now we're storing our input, and we can work on the rotation itself. I'll do this in the for each loop for the player. I'll start by getting the position for the player itself, and I'm going to store this in the camera offset. So I'll need a reference to the camera offset component. This will be var camera offset. We'll set this with systemapi.getComponent. The component we're looking for is going to be a camera offset. We'll be getting this from our player entity. I'll also store this in a temporary variable for the moment. This will be a float 3 value and will be called target position. This will also be set with a 0 vector. So after we update the player transform, we'll set our target position. This will be set with our transform. We'll use the value read only. And here we'll get the position with .position. I then want to add my camera offset to this position. And we'll get this with camera offset.value. This will give us the position where the camera is actually pointing to. However, before I do anything with this, I want to actually be able to see this. We're going to be drawing a gizmo for this. We'll do this with debug.drawLine. We will be drawing a line from our transform.valueReadOnly.position. And we'll draw this to our target position. I'll give this line a color, and I'll set this to be cyan. We should now be able to see the offset for our player's camera, and this should move when we move the player. So we're now moving the player. In the game viewport, we should be able to see our gizmo. We should also see that this is aligned with the entity and is moving in concert with it. In the scene view, we do not see the entity movement, but we do see the gizmo moving. If I select the player entity, I should be able to adjust the height of the offset using the parameters in the inspector. This is the position our camera is going to rotate around. It will also be the position to which the camera is pointing. These do not necessarily need to be the same, but they will be the same for the moment. As stated previously, we can always offset this from the character itself. So for example, we could offset this in Z as well. We could also move this behind the character, but having it in front of the character is generally better, as this can give us a better view of the character from the front. So this will give us the target which the camera is going to point towards. Next we'll need a vector which is going to rotate around this point. So we can return to our script. And while this vector is going to rotate, it's technically not going to rotate around the tip. Instead, we're going to rotate this vector around the world origin, and then we'll transform that vector into the space of the character. So we're going to start by getting our rotation. I'm going to store this in a variable rot. I do not, however, want to overwrite my existing rotation, so for the moment I'll call this rot A. This will be set with a quaternion, and we'll be setting this quaternion with Euler angles, so we'll use the Euler method, and this will be set with our rotation. I'll specify the type to be a var. So this will create a rotation from our input. However, this method takes radians, and it is generally easier to work in degrees than it is to work in radians. I will, however, not worry about this now. I'll set up my rotation first. After I calculate these rotations, we'll have a float 3 value, and this will be our camera rotation. This will be the basic rotation, so I'll call this base rotation. I'll set this with math.rotate. The rotation itself will be our rotation A. We're then going to rotate a vector, and I'll create the vector here. This will be a new float 3. This float will be 0 in x, 0 in y. It will then have a z value. For the moment, I'll set this to be 3. This should be enough to test this rotation. Once again, we'll test this by drawing a line. So this will be done with debug.drawLine. For now, we're going to test the rotation at the center of the world. We'll get a 0 vector with float3.0. We'll draw from here to the base rotation, and in this case I'll set the color to be yellow. We'll then attempt to draw this relative to the camera target. This will be debug.drawLine, so the first point will be the target position. We'll draw from this to our target position plus our base rotation. I don't like base rotation as a name, so I'll rename this to camera rotation. This will be our final camera rotation, so I'll give this a cyan color as well. And we should now be able to test and see if we have a camera rotation. So I see my two rotational values. One is relative to the world, and that is yellow. The other should be relative to my target. Both of these are facing towards the player, but they're facing towards the front of the player, and this is actually the opposite of what I want as a default, although this is not really a problem. I can then try and rotate this, and this is giving me some movement, but this is very small, and it is not the rotation that I want. This means I need to update my inputs. Once again, I'm not accumulating the rotation. This is the same mistake that I made with my transforms. With our translation, we've been adding the translation to itself. This approach won't work as well for the rotation though, so I'm going to add the values to themselves when we calculate the inputs, rather than when we calculate the final transformation. However, upon testing this, we still have the same issue. So we have an issue that is arising that the camera is not updating properly, even though we should now be accumulating the rotations. This is not working for our rotation, but it is working for our transform. That is because this transform is not actually stored as part of this update loop. Instead, it is a component on our entity. However, our rotation is being created as part of the loop, and every single frame we are setting this rotation to be 0. So for the moment, I'll cut this declaration, and we'll declare this outside of any of our methods. We'll not set any value here, but we will set a value on creation, as here we'll set our value to be 0. We can now test again. So we have our character movement still, but now we also have a rotation for the camera. We have a rotation which is exclusively in the X direction, and a rotation in the Y direction. There are of course a number of issues which we have with this camera. The first of these is that we do not want to be able to perform a full rotation in the Y-axis. We also do not want to infinitely add the rotations. While it's unlikely to have cycling issues where we'll cycle past the maximum float, we do have possibilities of losing accuracy, and that can happen faster than we'd like. So we will actually want to clamp our float to a basic value. So essentially we want to make sure that our vertical axis is limited, and that the horizontal rotations occur in a range from 0 to 360. I'll start with the vertical rotation. So we'll say if rot x, is less than -70, we'll set the rotation and X to be -70. We'll then specify our maximum. So if the rotation in X is greater than 80, then our rotation in X will equal 80 degrees. So in this case, we will not be able to go below 70 degrees, and we will not be able to go above 80 degrees. This is currently a fixed value. In the future, it will be better to make this value adjustable, but I'll leave these as fixed values for the moment. Next, we'll deal with the rotation in Y, which will be our horizontal rotation. I'll want to check if this is bigger than math.pi. We'll want this to be for the full circle, so we'll multiply this by 2. So if rotation.y is equal to math.pi times 2, we'll subtract 2pi from the rotation. This will be done with rot.y minus equals math.pi times 2. I'll need to do the same for negative angles. So if the rotation in y is less than negative math.pi times 2, I'll add math.2pi to the rotation. So we can test this, but it should not actually work. This will not work, and the reason that this will not work is because of the conversion of degrees to radians. These values should actually be radians. So instead of being -70 degrees, this is -70 radians. However, we're limiting this in degree values because that is easier to work with, so we will need to convert all of these degree values to radians. So this will now be negative math.radians, and we'll convert our value to radians. We will need to do this for all of our degree values. So this will be set with negative math.radians with a value of 70. We'll do the same for our maximum. This will be set with math.radians with a value of 80 degrees. This should convert all of our values correctly, and we can now test. And my rotation around the character's x-axis should now work correctly. We are getting a limited rotation. However, one thing that we should note here is that our negative value is actually representing our maximum, where the 80 degrees is representing our minimum. There is no problem here. We do need to note that this is how it works, however, as we can generally support a more extreme value for the maximum, as we generally will not contact the ground with this angle. So in this case, I'm going to set the low angle to be 60 degrees. So we've now got our camera working in terms of giving it the correct position and rotation. Next, we'll need to store these values and apply this rotation to the actual camera itself. So I'll duplicate my camera offset component, and I'm going to add more of my camera components. The first will be the camera position. The variable's name will be camera position, and this will reference the camera position. I have my camera target, which will reference my camera target. I will also have my camera distance, which will be stored in the variable camera distance. The first of these we'll use is for the camera distance, and this will be used when we set our rotation. When I set the float here, instead of a value of 3, we are now going to use the camera distance. So the Z value will be camera distance.value. The other values are not going to be used in this function. Instead, we're going to be storing values in them. So we'll set these using system API.setComponent. This will be set on my player entity. And what we want to set here is actually our target position, but we can't use this variable directly. This will also need to be set within the loop. So we'll set these values within the loop. We'll have our camera position, and this will be set with my target position added to my camera rotation. I'll need to set the value as this is a component. I'll then have camera target.value, and this will be set with my target position. So the first component we set will be for our camera position, and this will be set on our player entity. We'll do the same for the camera target. So we're now updating these values, and we can use these within the camera itself. This is actually not a particularly complicated process. First, we'll need a reference to our player entity to get our values. So this will be entity. The variable name will be player. We'll get this with system API.getSingletonEntity, and we'll look for an entity with the tag player component. We'll then need to get our components. The first of these will be our camera position, and this will be followed by our camera target. We'll get these with system API.getComponent. First we'll have the camera position, and we should get this from the player entity. For the camera target, we'll again use system API. We'll get the camera target, and we'll also get this from our player. I'll then update the camera's position. So this will be camera.position. This will be set with campos.value. So this is all we need to update the position of the camera, but we still need to make the camera look at the target. To do this, I'll update the camera rotation. So this will be camera.rotation. I'll set this with a method which we use on our quaternions, and this will be a look rotation method. So we'll use quaternion.lookRotation. Our look rotation will be looking from our camera position to our camera target. I'll get this by subtracting my camera target from my camera position. I'll then need an up vector. In this case, I'll use a unit vector in y. So this will be a new float 3. The x value will be 0, the y value will be 1, and the z value will be 0. I'll need to specify that I'm subtracting the values. We can now test, and we should theoretically have a working camera. Unfortunately, this is not working correctly. I can attempt to increase the distance, but this is having no effect. We can test to see what's actually happening by selecting the camera, and my camera is currently pointing in the wrong direction. So my subtraction is the wrong way around. I'll subtract the camera position from the camera target. So our camera is now facing the character, but we are still having some issues with the camera facing directly downwards at the top of our range and also not being orientated correctly at the bottom of the range. In this case, the problem is actually caused by our subtraction. What we need to do is normalize this vector so we have a straightforward direction. I'll do this with math.normalize, and then we'll subtract our camera position from our camera target. I can then save, and I should now have a very basic camera which will rotate around my player and will also follow the player's movement. These, however, are rotating the wrong way around, so instead of adding my rotations, I'm going to subtract my rotations. This is something we can make dynamic so that the player can actually set this value themselves, but I'll worry about that later. I now have a working camera. I can also adjust the distance of the camera from the player. Since the player is still working in world space, this is not the easiest thing to control, but it is working. Next, I'm going to add animation for our player.